So we've got another example of dividing complex numbers. So we have 6 divided by 1 minus 6i. So we want to get rid of our imaginary number in our denominator. So in order to do that, we're going to multiply by its complex conjugate. So its complex conjugate is going to be 1 plus 6i. And we also have to multiply by 1 plus 6i in the numerator. So if I go ahead and multiply these in the numerator, I get 6 plus 36i. So nothing left to simplify there. And in the denominator, I have 1 times 1, 1. 1 times 6i, 6i. Negative 6i times 1, negative 6i. And negative 6i times 6i, which is going to give us a negative 36i squared. My two middle terms cancel, so I'm left with 6 plus 36i divided by 1 minus 36 times negative 1. So I have 6 plus 36i divided by 1 plus 36. So that's going to give me 37. Now this is my final answer. I cannot simplify any further because 6, 36, and 37 don't all have something in common. So 6 plus 36i divided by 37 is our final answer. Here we have another example of dividing complex numbers. So go ahead, write this one down and give it a try. When you're done, go ahead and play the video to go through and check your answer. So hopefully you've come up with an answer here, and what we're going to do is we're going to multiply by the complex conjugate. So our complex conjugate is, as we hopefully saw, negative 2 plus 7i. Now remember, our first number, our real number, does not change. It's just changing the sign of our imaginary number in order to get those to cancel. So if I multiply that in the denominator, also multiply by my complex conjugate in the numerator, I'm going to go ahead and multiply that through. So 10i times negative 2 is going to give me negative 20i. And then 10i times 7i is going to give me 70i squared. And I'm going to go ahead and divide that, and when I go through and multiply, negative 2 times negative 2 is a positive 4. Negative 2 times 7i is a negative 14i. Negative 7i times negative 2, positive 14i. And then negative 7i times 7i is a negative 49i squared. So now it's just going through and simplifying. So my two middle terms here are going to cancel. So I'm left with negative 20i plus 70 times negative 1 divided by 4 minus 49 times negative 1. So I have negative 20i minus 70 divided by 4 plus 49. So I'm going to write my number first, negative 70 minus 20i divided by 49 plus 4, which is going to give me 53. Nothing is going to simplify, so this is my final answer. Large numbers, but that is our answer, negative 70 minus 20i divided by 53. And our last example here, we have negative 5 plus 8i divided by 3 minus 4i. Now remember, in order to rationalize our denominator, get rid of that imaginary number in our denominator, we have to multiply by its complex conjugate. In this complex conjugate, we are flipping the sign of our imaginary number. So we would multiply by 3 plus 4i in the denominator. But in order to keep our problem the same, we have to multiply by 3 plus 4i in the numerator as well. So then we're going to go through and multiply. So the only difference in this one than the previous examples is we're going to have a lot more simplifying to do because we have two binomials in the numerator as well. So when I go ahead and multiply this in the numerator and the denominator, I get negative 5 times 3, which is going to give me a negative 15. And then negative 5 times 4i, which is a negative 20i. Then we're going to go through and multiply the 8i in. So we have positive 8i times 3, which is going to give us a positive 24i. And then 8i times 4i, so 8 times 4 is going to give us 32. And I times I is I squared. Now if we go through and multiply our denominator, we have 3 times 3, which is 9. 3 times 4i, positive 12i. Negative 4i times 3 is negative 12i. And negative 4i times 4i is negative 16i squared. So remember, in our denominator, because we multiply by its complex conjugates, our I, our imaginary numbers, cancel. And then our other big thing is I squared, remember, equals negative 1. So I squared becomes negative 1, and I squared becomes negative 1. So if we go through and we simplify, we have negative 15, negative 20i plus 24i is going to give us a positive 4i. And then 32 times negative 1 is negative 32. In our denominator, we have 9. And then we have negative 16 times negative 1, which is going to give us a positive 16. So if we go through and finish simplifying, we have negative 15 minus 32, which is going to give us a negative 47, plus 4i, divided by, we have 9 plus 16, which is going to give us 25. 47, 4, and 25 have nothing in common, so here is our final answer after we've rationalized our denominator.